Hi, everyone. Thank you so much for joining us for our September Mid-Market Tech Talk. Today we have Naz Nageer here talking to us about containers and solutions pertaining to them. If you have any questions throughout the talk, please feel free to put them in the chat and we'll make sure to get them answered. With that, Roger, I will pass it on to you.
Thank you very much, Kat. I appreciate that. And I appreciate everybody taking the time to go ahead and tune in and hopefully allow us to educate you a little bit on something you may not be real familiar with. And today we're really lucky. Today we've got Naz Nageer with us, and I have a feeling just from talking to him briefly that he knows more about this subject than I'm ever going to know. So I think we're in good hands. And, why don't we start off, Naz? Why don't you just tell us a little bit about you and your journey to this point, and then we can jump into things.
Great. So welcome everybody, Naz Nageer. So current role is America's sales leader for storage for Red Hat OpenShift. I'm actually more than just a sales leader, I'm a specialist. So I actually help do solutions. Prior to that, some of you may have known me as being the sales leader for IBM Cloud Object Storage. And that's really where my venture with IBM started about in 2016. I came across with the CleverSafe acquisition, right? So that's my roots. And prior to that, I've worked with Oracle, Sun, for several years. And then prior to that, I've been a customer for the majority of my career. So bring a unique perspective to solution. So glad to join you guys today.
Excellent. And you and I came into IBM about the same time. I came in 2015 when I left NetApp, and the two companies I was looking at going to was CleverSafe and IBM. And I chose IBM, and then about 6 months later, we acquired CleverSafe. So I guess I could have got here either direction, but I'm really pleased to have you with us today. And, you are addressing an area that is so hot right now. And it's also an area that, while everybody who has anything to do with storage knows about containers, most of them don't really know about containers. They've heard it, they can conversationally discuss it, but unless you're actually involved in it, it seems like most people just have a cursory understanding. So could you perhaps help folks out a little bit and just explain a little bit about containers before we really start to get into things?
Sure, be glad to. So containerization technology, I mean, if you guys have been in IT for numerous years, like Roger and I have, the pendulum swings, right? So containerization, we started with, our mainframe kind of workloads where you had a server, you had compute, everything was in one particular silo. And you had multiple versions of that, whether it's, a legacy mainframe, a power kind of deployment, or many computers. Then virtualization came around, and we applied virtualization to those hardware infrastructure. Virtualization was good. It allowed us to take an image, or it allowed us to get better hardware utilization, right? You had all this compute capability. We were deploying applications on them, and people were building, one physical server, storage, and everything for a specific application. And then there came a realization that, I've got so much compute network storage out there that I am not being very efficient. So along came virtualization, hypervisors, which allowed us to put a hypervisor layer on top of our operating system. So, our typical deployment, you had a server, compute memory, and operating system and application. So where hypervisors fit in is they fit above the OS, and it allows us to create a virtual infrastructure that now you can take those machine images and run them on one physical server and get better utilization. Great technology. We've been living with it for the last 20 years, but it created a new problem, what we call server sprawl or VMware sprawl. So how do I update each of those images, right? Because a virtual machine is really just a machine instance. It has its own OS, it has its own binaries and everything specific, but it did have its complexities. As we know, and technology continues to evolve, containers came into play, and containers allowed us to run just that specific application logic, its binaries on an OS, and really remove or replace the role of a hypervisor, which we call a containerized OS, right? And so on top of that, we can take these little images of our workloads. And then, so that actually, containers actually introduced more kind of advanced features. Not only can those containers take an application that was running in a VM, but it could break them down into microservices. I could refactor them. I could actually get more agile with my infrastructure. So I can take a legacy apps, for example, an ERP, which had like different components, and I can create those into their own little container images, and I could deploy them as services, microservices, and let the container platform scale them up and scale them down as I need. So that's really what containerization allows us to do, to have a more agile development platform for future, what I call the next gen apps, which we're doing now. So hopefully that helped, Roger.
Yeah, I think so. And a lot of folks, I've had a lot of people approach me and ask me, well, so is it a case of VMs versus containers, or do they peacefully coexist, or is there a reason to maybe want to head one way more so than the other? I mean, do you have any thoughts you'd like to share on that?
Yeah, so for me, I feel that they're like competing technologies, right? At the core, they're competing technologies. Um, but does that mean containerization technologies cannot run on virtual infrastructure? Absolutely, they can. But from a pure technology perspective, VMs and containers are just two different approaches to application modernization. I think containers give us a better platform for modernizing our apps, for creating, the ability to support a hybrid multi-cloud capabilities. If I want to burst an application from on-prem and burst it to the cloud, I can't do that with VMs, right? I can do that with containerized technologies. So containerization in general will give you a more modern platform for supporting hybrid multi-cloud, right? And I'll tell you guys the truth. That's really why IBM acquired this technology that we're going to talk about today from Red Hat. It's OpenShift. It's a Kubernetes containerized orchestration platform, right? So.
Well, excellent. And I'm actually kind of glad to hear you describe it that way, because while I certainly, I utilize VMware frequently in various aspects, but it's a lot heavier of a virtualized technology than containers. And one of the really beautiful things about containers is how easy it is to spawn them and scale their growth. And see, for people that know me, I just got goosebumps, which is sad because that's so nerdy. But, one of the really beautiful things with containers is how quickly I can scale them because they're so lightweight.
Right.
And I have to admit, I don't mind not having to deal with certain companies and their licensing structure for their virtualized environment.
Great.
So, I am pleased to hear you, address it like that. And if we could, I know you're doing a lot of work with IBM Spectrum Fusion.
Right.
Within IBM, this has been a very hot area, very hot item to deal with. Could you perhaps educate us some about what it is that IBM is providing?
Right. Sure, be glad to. So one additional note on containerization technology, and it's a key mantra. It supports this, and this is a core difference with virtual infrastructure, is build once, deploy anywhere, right? Once I build an application for a containerized Kubernetes, and I'll get into what Kubernetes is. So we have containers, and then we have orchestration, which really controls the bursting up, bursting down. Did a container that's running in a node fail? How do I spin it back up? So orchestration is really a key part of the containerization, bursting, scale up, scale down, just creating a high availability application cluster. That's really core to the containerization OpenShift technology. Going back to what we are doing with storage for this environment. So I'll just pause right there. So for us at IBM, we we're moving towards containerization and orchestration because that will give our customers the next gen, what we call hybrid cloud platform. And when you look at the market space of who provides that Kubernetes orchestration, who provides the best enterprise Kubernetes orchestration platform, it's Red Hat. They are the market leader, and I'll reiterate that is one of the primary drivers why we acquired them, is to get a hold of that technology. Now that we have it, you are seeing it, we're using it throughout the IBM stack. We know our customers are containerizing, they're modernizing their apps, or they're doing a cloud first strategy, right? We are shifting the pendulum, so to speak. So from an application perspective, IBM has modernized all of their application software into these things we called IBM Cloud Paks, right? Whether it's DB2, Watson services, API Connect, MQ. What we've done is we've containerized all that software and put them in these Cloud Pak bundles, which are, it's really just a bundle of those application services that run on top of OpenShift. And those Cloud Paks help our customers accelerate their journey to the cloud, whether it's a DevOps, a data AI kind of strategy, or it's an application integration in the cloud or on-prem, right? And so that's our application strategy. The storage team decided we're doing the same thing. How can we provide storage, or what I'd like to call it is data services? The things we've been doing in the system storage world for years, we now have to extend those to an OpenShift world. What does that mean, right? We want to provide backup. We want to provide HA, recovery. We want to be able to provide the ability to monitor the performance of our services. We want to be able to do stretch clusters, the kind of capabilities we've been doing in system storage. We want to provide those capabilities to an OpenShift world, right? And the goal is really to be infrastructure agnostic. And I like that word. As OpenShift is infrastructure agnostic, whether it's the applications that sit on top of it, the Cloud Paks, our storage services, or what I would call data services, also need to be infrastructure agnostic. Whether we are deploying that workload in a public cloud, Amazon Web Services, Azure, GCP, or the IBM cloud, we can deploy them there, but we want to be able to provide consistent data services, right? Similar on-prem, whether you're doing it on an x86 bare metal infrastructure, whether you're doing it on a customer's VMware infrastructure. I'll actually tell you a little statement of fact here. Red Hat OpenShift's number one on-prem deployment is on VMware infrastructure. So I can deploy an OpenShift cluster on top of VMware. They're not rather than deployed on physical servers, you're virtualizing the servers in that cluster. So it's all like VMs, right? Virtual machines, but they're mimicking worker nodes, master nodes, blah 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 blah, right? So the goal is, from an application perspective and a storage data services, we want to be infrastructure agnostic, right? And follow that. But I will say that we love hardware at IBM. And if a customer wants to deploy a Cloud Pak or a third-party OpenShift workload on-prem, we've got a kick-ass appliance. It's called our Fusion Hyper-Converged Infrastructure that runs bare metal OpenShift workloads like you can't imagine. So it's an awesome device. So love to talk to you guys further about that.
Roger, sorry for the interruption. We actually had a question come in, and I think it would actually be kind of relevant to what Naz was just talking about. The question is, if a customer is on VDI, VMware and Citrix, can containers replace or improve VDI?
So it's a virtual desktop infrastructure. That's an interesting question. I'm not sure if those workloads have been containerized and can run on top of an open. So the answer would be is if VDI, it's because virtual desktop infrastructure is a whole application stack. If that can be containerized, yes, but I'm unfamiliar with that, the cat, so I'm not sure about that specific workload.
Okay, no problem.
So that was a good question, Doug, that you asked. And I had seen that come in and was trying to figure out where a good place to insert it. So I'm glad you stepped in, Kat. That's great. Gosh, it really is a pleasure listening to you talk about this because about a year and a half ago, I got tasked out of my group to work on Spectrum Fusion HCI. And, as we were working on it, we were also talking about Spectrum Fusion as software defined so that, as you've been indicating to us, you could put it anywhere. If we want it as a hardware appliance-based solution, we've got it. But if we want to locate it in somebody's data center where they don't need that stuff or up in the cloud, we now have that as a solution. And the fact that Red Hat OpenShift allows us to just seamlessly tie in all of this is really impressive and amazing. And, I've seen some just stunning, almost hard to believe statistics from analysts and things that talk about what the potential ROI is on this and just the total cost savings over, a standard period of ownership. So it really is good to hear you, talking about these things and sort of tying these pieces together. And you brought up the storage suite for Cloud Paks. A lot of us, and I'm guessing a lot of the folks on this call, got used to talking about storage suite for Cloud Paks, and now what we're hearing is, well, let's really talk about Fusion because we have a better way of delivering this capability. And, would you maybe touch on that just a little further?
Sure. Actually, I love talking about storage suite for Cloud Pak because for me, that is the evolution of how we got to Spectrum Fusion, right? So if you guys are familiar, storage suite for Cloud Pak was really just a bundle of two products from Red Hat, and 4 products from IBM, it gave you entitlement to use it. It wasn't software, so to speak. It was just entitlement, and you would connect those stores. So why would we have 6 products? It depended on whether that specific cloud pack had a certain affinity for file storage or for block storage, what we call in the Kubernetes world as access modes. Read write once, you can equate that to block. Read write many, you can equate that to file, or if they just wanted object storage. So that's why we had those suites. And then those products in the suite was to be able to connect that to all our applications running on top of OpenShift as a persistent storage layer using storage classes, persistent volume claims, persistent volumes. So your storage admins were involved, right? They would set up the LUNs, then those LUNs would be connected to persistent volumes, and then our workloads had storage classes and claims that went against those. So that was a great mechanism. I like to view that as the plumbing, and we provided great plumbing. But over the course of the last 3 years, we saw complexities, right? It's a complex world. Everybody is doing that kind of plumbing, and there are common standards for the plumbing. It's called CSI, Container Storage Interface. It's a Kubernetes construct, right? So we support it. Lots of other people support it. There were complexities. How do I not only provide that, but how do I back it up? How do I recover it? How do I integrate to legacy storage? How do I handle performance? And these are things that we have been doing in system storage for years, and we knew we needed to provide those kind of capabilities in the OpenShift world, and we've been working in the background. And we saw it migrating. We saw the need for our customers migrating from container ready storage, container native storage to what we call data services, which is an evolution of just underlying plumbing, where data services are broken down or exposed at the application level. And some of the common data services we saw customers needed was backup or data protection. So I classify data protection as, backup, recovery, migration, clones. So we saw customers needed that, and they needed it at an easy to use integration level, right? Not that you couldn't do it. We had lots of products, point products, you could do that, but it was complex. And in this new world, OpenShift or any of the other Kubernetes, there's a learning curve, right? There are some very mature customers out there, they're leading edge, they got it, but the majority of the market is still learning this. And we needed to create a simple turnkey kind of solution to expose these data services to them. So primary data service was data protection. HADR was another one, right? So HADR, how do I, if I have 2 clusters, primary data center, secondary data center, how do I handle if one cluster goes down and bringing up the other cluster? We know that underlying storage services have been doing stretch clusters for years, but how do I make sure that the application fails over? And you can have an active, passive. So these are the kind of things that were top of mind. There were lots of other things, cataloging unstructured data. But what we wanted to do with Fusion was create data services that a user of the OpenShift, as they are deploying their applications, they can easily attach these data services to their application workloads. And that was our goal. And that, guys, is what Spectrum Fusion is. It's an application that sits next to your OpenShift workloads, whether it's Mongo, whether it's our cloud packs. I have a console integrated into the OpenShift console that launches Spectrum Fusion Data Protection or Spectrum Fusion DR recovery kind of capabilities. A lot of what I'm talking about, the data services are coming, they're evolutionary, but we have the core ones that most of our customers need: data protection, HADR, right? So it's really more of an integrated experience. So think of SS4CP as the storage layer services, the underlying storage layer services. I want you to think of Spectrum Fusion as extending those underlying storage layer services as data services core capabilities that the storage provides, we now expose them as data services to all the applications running on OpenShift. It's a UI. It's an application that extends those capabilities. So Roger, that for me is the primary difference between Storage Suite for Cloud Paks and Spectrum Fusion.
Okay. Well, and you just said quite a bit, but one of the things that you had mentioned, and you'd mentioned it previously, were things like container storage interface, and IBM Flash system line supports container storage interface, and we're container ready. But you also mentioned container native. Could you perhaps expound on that a little bit and maybe help people see what that difference is?
Yeah, I'd be glad to. So one for me is connecting to storage that lives outside of the OpenShift cluster. So within an OpenShift cluster, you have this construct of master nodes and worker nodes. The master nodes are where Kubernetes runs, and they, do the scaling, monitoring, keeping our worker nodes up to date and up and running, and making sure they're getting the kind of service levels they need. So that's the cluster. And each one of those worker nodes need persistent volume. How I mount the persistent volume is either with container ready storage, which exists outside of the cluster, or container native service storage, which lives within the cluster. That means I've defined some worker nodes that actually are having like virtual disk associated with them. I like to call them storage-rich virtual worker nodes, which they have virtual disk associated to them. They create a cluster and then expose that cluster to internal. They expose it internally to workers running within the cluster. I have a really great picture I could share with the team if that would help. If you want, would this be good to show that? I think we could walk through it.
Sure. If you have that handy, that'd be great.
Yeah. Well, let me pull it up. It's actually a great slide. It does.
And while you're doing that, I'll just mention to folks, one of the great things that Naz just said was persistence, that ability for that data in the container to live. Even if something goes wrong, it's still available. It hasn't just disappeared into the ether. So whether it's, as he described, outside of that cluster or within, you have data persistence. So no matter what happens, your data is still there. It hasn't just gone poof somewhere.
It looks like I cannot share. So
Oh.
Is it an easy file you can just Slack me and I can share my screen? Would that help, or is it kind of?
Yeah, it's okay. So, and yeah, we'll not deal with those complexities.
That gives us a reason to bring you back next time to where we can do this. So this is really fascinating, and I am really pleased that we were able to get you to come on and talk about this, because I think over time, a lot of people, I've certainly had a lot of people outside of IBM ask me, why did you guys buy Red Hat? And why did you pay what you paid to get Red Hat? And the problem is, for folks that aren't really in the storage industry or data centric in their thinking, there's a lot they don't understand. But I think you've done a great job sort of explaining that this underlying technology, this Red Hat OpenShift, that gives us this seamless portability over all these environments, on-prem, cloud, edge, and cloud, we don't care who's cloud.
Right.
It's incredibly powerful. And it is, honestly, people think it's a little melodramatic, but it's freedom. That's really what it is. It's freedom. There's no vendor lock-in. You're not stuck with a decision that you might have made and now realize, oh, we really should have put our stuff over here.
Right.
I don't think it gets any easier than when it's been containerized and gained that portability.
Right, and software defined, right? So, and then when we talk about software defined, we really move ourselves away from being locked in. And even the cloud vendors, even though you think you're cloud, you think you're infrastructure agnostic, you're not, because when you, like for Amazon, for example, AWS, and you need persistent storage, they have an offering called elastic block storage or elastic file storage that you do your persistent volumes from. But if you think about what that is, it's really container ready storage. It's their infrastructure storage, and it's not native. When you've built container native storage, whether you're using, on our offerings, we have container native or container ready, right? So depending on what you want to use, we will give you the best of both worlds. If you use a container native storage, you are really moving storage up a level and providing greater flexibility, mobility. You could start on-prem, take that same workload, deploy it into a cloud. It doesn't lock you into a specific cloud vendor. So really great story there.
Oh, fantastic. Well, we're just about to the end of our time, but let me just ask you, is there anything you'd like to make sure that people walk away with?
Right. Well, the one thing, guys, is I want you is to listen to your customers, understand what they're doing as far as their cloud journey, application modernization, listen for things like containerization, modernization, microservices. Listen for OpenShift. If they say they are looking at OpenShift, a lot of people, guys, they like OpenShift, just like they have liked RHEL. You know, Linux was open source, 30 flavors. Who came out on top? Linux is very complex, and there are some guys out there that love turning knobs, but the majority of customers like the easy button. RHEL, Red Hat Enterprise Linux, was the easy button for Linux. Red Hat OpenShift is the easy button for Kubernetes and containerization. A lot of our customers are going to go there. Once they go there, they're going to want data services. And so any application, whether it's a cloud pack, whether it's a third party, it's going to run on OpenShift. We are the data services for that OpenShift environment. That's what we have to do. Identify if our customers are doing OpenShift and promote our solution, right? That's it.
That's fantastic. I really do appreciate you taking the time out of your busy day to come spend with us and just help educate us all. This is fascinating. I get so much out of these mid-market tech talks. So this is great. And thank you everybody who came today and tuned in to listen, or perhaps who are listening at some point in the future. And with that, I'll turn it back over to you, Kat.
Perfect. Thank you, Roger. And again, just to reiterate, thank you, Naz. Just as a reminder for the attendees, this session was recorded and we will be posting it to our Mid-Market Tech Talk YouTube page, where you can obviously this session and our previous sessions. And we look forward to seeing you on our future talks. Have a good day, everyone.
Thanks, everyone.